Hi guys, how was contest? I'll keep a poll maybe. Like the video, guys. Let me make a folder for today, Jan 12, right? And open it in VS Code so I don't show you guys any sensitive information of mine, like my nudes. Maybe if iCloud Drive is storing them, I don't know. I don't think it does. Yeah, where are we? Uh, 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 uh. It's not my room, it's my brother's room. He is a big anime fan. Do you guys want to see something else? There are some anime waifus over there. There are some anime waifus over there too. But yeah, first let's do the contest. Like the video, guys. It's not my room though. Yeah, it's my brother's room. If we solve well, I will show you guys those anime pictures. Okay, we have nice anime girls over there. Yeah, every stream I'm in a new room. I'm in a new city now. I'm in Hyderabad now. Yeah, I'll share my screen. I'll try to live solve problems. Okay, like the video, guys. We need 10 likes at least to solve the problem. Okay. Anime girls show. Thank you. Thanks a lot. I'm an expert. If you guys are doubting my skills. So yeah, we are going to live solve problems now. Okay. We're going to live solve Codeforces round 3. I'll start with C maybe. Okay. Hi Asphalt. It's been a while, I guess. I have seen you over here. So yeah, we'll try to solve these problems. It's blue, so I haven't yet opened it. This is the first time I'm opening it. So I'll start with D because it has 4k solves. Okay. I think we can solve everything. G itself is having just 820 solves, right? So let's read the problem first. I'll remove this shit. Wait a minute. But if I remove this shit, will it get disconnected, the audio? Where should I keep them? I'll do D and then U, okay? Hi guys, we have expert here. Okay, we need more viewers because an expert is solving. Bob is tired of losing to allies and to ensure he doesn't lose again, decided to choose a game in which he is guaranteed to win. Bob thought of a number from 1 to n where we know that n equals to 2 power d for some non-negative integer d. So Bob has chosen some number which is a power of 2. Initially, allies knows whether the chosen number is even or not. So allies will only know if if d is 0 or not, right? In one move, allies can either half the number or subtract 1. Allies can only half the number if the current number is even. Only allies takes turns. After her move, so what allies can do in one move is either do -1 or do by 2. Okay. After her move, allies receives a response from Bob, either -1, which means the number has become 0 and allies has 1, or a non-negative integer x. So it's, I think the number is always positive until it becomes 0, because by 2 will make it positive. -1, if it is not making 0, it will be positive, right? If it is making 0, the game ends. Okay, so number is always positive. If we denote the current number as a, then for x the following conditions hold simultaneously. If we denote, what does it say? Or a non-negative integer x. So Bob will return -1, or he returns a non-negative integer x. If we denote the current number as a, then for x the following conditions hold simultaneously. A is divisible by 2 power x, and a plus 1, and a is not divisible by 2 power x plus 1, which is nothing but he will give what is the highest power of 2 that can divide it, right? He's just giving the highest power of 2 that it can divide. If a is odd, he gives 0. If a is 2 power something times odd, okay, this makes sense. This, okay, Bob will return that. Now for example, if a equals to 2, then x equals to 0, 5 is divisible by 2 power 0. Yeah, it's just like how many 2 powers are divisible by that. So the thing is, here things are seeming obvious, but we are using logic. Like if you be careful, like I'm using logic all the time. I'm using logic to see that it is positive, because I'm using logic when we either do half or we do -1. So I'm using logic to see in these two cases it will remain positive, because -1 of a positive number will become 0, right? It cannot go directly. It cannot jump directly to negative. So you have to be careful in what you're not careful. You have to know what you're doing. Okay. It can be. That's why I think writing down is better. But I'm just reading the problem still. Uh, so now what Bob is still afraid. It can be shown that for any integer a greater than zero, yeah, this is also obvious, right? There is an unique x. This makes it there is an unique x, because everything less than this is also divisible. Everything more than this is not divisible. So there is an unique x. Bob is still afraid that Alice will win, so the game will have no more than K moves. Additionally, Bob wants to maximize his chances of winning, so he wants to play as many games as possible. Given N and K, problem is becoming complicated. It's having too many things, but we have to read the problem. We have to try to simplify the problem. That's all problem solving is, right? So let's try to read the problem fully. Additionally, Bob wants to maximize his chances of winning, so he wants to play as many games as possible. Like if you guys are getting scared of D, you have to read much difficult problems. You have to read them calm. You have to try to solve them calmly. Okay. See, the thing is, you will get scared in 1 minute itself. Like you have to spend 5-10 minutes slowly to read the problem. Additionally, Bob wants to maximize his chances of winning, so he wants to play as many games as possible. Given N and K, calculate the number of. So the game will have no more than k moves. Given N and K, calculate the number of initial numbers from 1 to n such that Allah is playing optimally, because the answer can be simple. Like the problem has steps, right? Once you solve this problem, once you solve something about the game, then you can come and try to solve something about what they are asking. So it has steps, so you guys need not get scared of problems. Calculate the number of initial numbers from 1 to n such that Allah is playing optimally cannot win no more than k moves. So we have a number n, we have a number k. We want to find for number of integers between 1 and n, allies cannot win in less than or equals to k moves. Wait a minute, what does that mean? Playing allies cannot win in no more than k moves. Okay, allies wants to win in more moves. So what does that mean? Whatever allies does. So I think doing -1 is the best, right? Allies can keep doing -1, -1, -1, -1 to maximize her moves, which will take 2 power d moves. I don't see this problem. Is the answer 4 minus 2? Let me think about the problem again. Alice receives a response. Alice. What does that mean? Cannot win in no more than K moves. Oh, okay. We want to find in which you cannot win in no more than K moves. So value must be less than or equals to 2 power K. Why? If the value is greater than 2 power K, sorry, what I mean is, like if 2 power D is greater than or equals to K, allies can win in more than K moves, right? So we want to find after allies playing optimally cannot win in no more than K moves. Is it just number of numbers less than or equals to 2 power? Wait a minute, I'm not still understanding. Is it just number of numbers less than or equals to K? Is that it? Should you guys help me out? Let me try to understand. I think I became if you see my graph, I think currently I'm pupil or something, right? See, I was international master few days back, but currently I think I mean I haven't given contest, but I'm likely here right now. I'm likely in pupil or like specialist. Okay, so give me some time. Okay, give me some time. I don't know where I am. Maybe I'm in newbie. I don't know. Like how is it falling? Can we extrapolate it and see where I am right now? Uh, Calculate the number of initial numbers such that allies playing optimally cannot win in no more than Kemos. What does that mean though? Allies cannot win in no more than Kemos. When will allies win? If the number becomes zero. Let's see an example. A equals to A. I never do that, but let's see an example because I came to newbie, right? So let's see an example. A equals to 4 are suitable because for A equals to 1, no one can reach 0 in one operation. While for other values, it can be shown that at least 2 operations are required. Cannot win in no more than Kemos. Playing optimally, no more than Kemos. So she cannot win quickly. So we want to find numbers in which she cannot win in less than or equals to Kemos. I think that's what the problem is. In less than or equals to Kemos. Okay, this is what we have to find. Because that seems the answer, right? So if Alice reaches some 2 power d, I think from there onwards, okay, if Alice reaches an even number, from there onwards, doing it by 2 is the best, right? So if n equals to, if n's bitwise representation equals to this, if Alice is at some even number, doing -1 is bad because that will only make things worse. That will make it like this. Now you cannot do by 2 until here because it has to be even to do by 2, and then you have to do -1, and then you have to do this. I think greedily likely always by 2 is the best. Let's assume that for now. Okay, it seems nice, right? It seems right. So is the answer by 2 plus, whenever there is 1 you do -1. Okay, number of active ones, number of bits is the answer, is the optimal way, number of most significant bit, let's say most significant bit plus number of ones. Is this the answer? Because you have to remove all these things, all the numbers after that, which will represent by most significant bit, and you have to most significant bit index, let's say, a number of ones, because -1 you will do only on the right. This is the optimal way. Now you want number of numbers for which the above value is less than or equals to k. You have a number k, you want number of numbers for which the above value is less than or equals to k. Above value is greater than k, you want this. Okay, both of them are fine anyway, like whatever the problem is. Cannot win in this is can win in that. You want this for which this optimal, even the optimal will be greater than k, because if you see here in one move for 3 you have most significant bit index is 1 plus 2 active bits, that's 3. You cannot do it in one move. For 4 you cannot do, for 2 you cannot do. But how do we count them quick? N can be large, but it's 2 power d. Okay, n is 2 power d, but it can be large. So what is simple? Things look complicated here, right? But what is simple? Always you have to think about what is simple, what is less, what is simple. What is simple and what is less is this thing doesn't have much possibilities. Even this doesn't have much possibilities, but this thing doesn't have many possibilities, right? This thing doesn't have many possibilities. So if you fix this one, let's say you're fixing that, okay, you're fixing that, and then you have these things can take some possibilities. Okay, if you're uh, fixing that in the sense, now you're trying to see the whole group of these numbers. So 1 less than or equals to x less than or equals to 10 is many sets, right? But if you split that set, s equals to x 1 less than or equals to x less than or equals to n into si equals to, let's say, x, where msb equals to I, x less than or equals to n. Okay, if you now you look at this set. In this set, okay, you want the remaining x's, which are like I x's. Let's say you have I x's, this to have less than or equals to some number of bits. Why? Now this shit is fixed, right? Now this shit is fixed. So now you know what this number is. You want this number to be greater than something, okay? Uh, and that counting that is not difficult again, right? So it's all like, it's not too difficult of a problem. It's like you have to just do it in steps, okay? How to do things clearly. So now what among this you want? Let's fix the other number too, okay? Let's fix the number of ones too, okay? Let number of ones be z in this. Okay, now you are fixing this number of numbers. You're fixing this number of ones be z, let's say. Okay, you want number of ones after this, let that be z. You have I plus 1 plus z. This is the optimal way to go. You want this to be greater than k. You want number of such numbers. Okay, you have I values, let's say, over here. You have I values, let's say, over here. So z can be 0 less than or equals to I, and you want number of values for which this is satisfied. Okay, this will give you a range of z, because this is already forged. This will give you a range of z, and for that z, let's say you're having z0, z1 remaining, or 0. How many ways you can do that? It's the most simplest, right? You have I x's, and z of them takes 1, rest 0. So this is nothing but choosing a z length subset, right? Which would be NCR of z comma I comma z. So you have I things. You have to just choose z things. So how many of you have solved the problem also? Because you see here, if k is big, this will anyway fail. If k is like greater than 60, this will anyway fail. So k is always small here. So if k is small, also z is small, I is small, because number of bits is small, right? I is small, z is small. You can brute force all of them. So is this clear, guys? I mean, is this problem has some difficulty in it? If anyone of you haven't solved the problem, you have to question yourself why you haven't solved the problem. Did you get scared at some point? Is this too much of a mental work for you to fix two variables which are obviously the only two variables that are existing in an optimal way? Like, because it had too many steps, you got scared. What is it like? Because you cannot do some work, you'll get scared easily, or like you're lazy, I guess. Even I was lazy last contest. Here I was lazy somehow in my last contest. For C, I wanted to. I don't upsolve, which is very bad habit, but I don't upsolve somehow. I'll do other things. I'm very busy, I guess. Uh, I'm not even practicing CP. In C, I thought both sides, it doesn't matter which size, but then it ends after touching one thing. I don't want you to do binary search because I thought it's possible without doing binary search. Uh, yeah, because of that, I was not liking to solve the problem. Even though rating is important, I was not liking to solve because I thought it can be done without binary search. I thought it can be done without giving importance to the length on this side and the length on this side. Because I thought optimal will have maximum side and then minimum will be less than or equal to that. So I thought only maximum size will matter. So I thought the other side will not matter, but it matters. Yeah, but it matters. Even this is not too difficult if it's having 700 solves now. All easy problems, but I cannot solve them. So guys, this is not difficult. You fix I, you fix you fix I. You have optimal way having two things. You can just fix this. You can just fix this, and then you can try to apply conditions that even you can just do that. You can just fix this. You can just fix this. This NC I comma Z will make sure that 0 is less than or equals to Z less than or equals to I, because otherwise it is 0. And then the problem is done. And then you have to apply this condition too. So it's very direct of a problem, right? Let me just write an algorithm like I will brute force I will brute force Z, I will brute force NCR. Okay, how do I brute force NCR? I'll just use modulo or other things. Okay, I don't want to use power. I'll make an NCR array. Define M D can be maximum bit can be like 30 or so right here, because 2 power 30 is greater than this. Let's define NCR for M itself, right? Okay. Where is mod though? We don't have mod. So we can store all these NCR values. So what is NCR formula, guys? NCR equals to NCR minus 1 plus N minus NCR equals to N minus 1 CR minus 1 plus N minus 1 CR. How do you see this? What is NCR? NCR is choosing or things from N. Right. Split these two things into subsets containing one, not containing one. So not containing one means N minus 1 possibilities to choose or things. Containing one, N minus 1 possibilities to choose or minus 1 things, because they already have one. We want to complete or. So this is just the formula. NCR formula is like this simple, okay? It comes from the definition very directly. So now I will make it, I'll initialize all of them to 0. And then I'll use the above formula for I less than or equals to M. I think NCR of 0 is 1. You can see this using some other, I don't know. NCR of I of 0 is 1. For int j equals to 0, j equals to 1, j less than M, j plus plus, NCR of I of j equals to NCR of I minus 1 of j plus NCR of I minus 1 of j minus 1, as we have seen above. Okay. So now we have NCR. Let's get NCR for other values to where r is greater than n or so. If r less than 0 or r greater than n, return 0. Else return NCR of n or n of r. Okay. So now we have n comma k. Okay. I'll just write two loops. I equals to 0, I less than or equals to d, right? Let's deal with I equals to d separately. Okay, let's deal with I equals to d separately, because if if I is less than d, you're sure that all of these can be anything. But if I equals to d, let's just handle that separately. I equals to d, for I equals to d, what is the answer? For I equals to d, everything must be 0. Okay, for I equals to d, you need d moves plus 1. Answer is d plus 1. If d plus 1 is greater than k, answer is plus plus. Okay, we will deal that separately. I'll get the D too. Let me just get the D. While 1 power D is less than n D plus plus. So we have the D2. What is initial answer if D plus 1? Because D is the number of zeros after 1, right? And 1 is the 1. If D plus 1 greater than K, that is an answer, because you cannot do in no more than K moves. You at minimum takes more than K moves. So you cannot do in no more than K moves, okay? Because minimum itself takes more than K moves. So now I less than D, because I cannot be D right now. For all these things, we'll brute force Z2. Z equals to 0, Z less than or equals to I, Z plus plus. Okay. Now what's the answer? If I plus, we want number of ones. I plus 1 plus Z, because what is this 1 coming from? This is the leading one, and then you're brute forcing, you're having Z ones. If this shit is greater than K, you have to count that. Answer plus equals to NCR of I of Z. That's it. That's just the problem. Is coding difficult? Is writing this shit difficult? This is minimum. Minimum greater than K is what they are asking you to find. See, it paused. So if you haven't solved this problem, you have to think what was the difficulty. You thought it will become too complex. It's a simple code. NCR, there is no memory here, okay? NCR is easy to get. Even if you forget the formula, it's easy to get. So now we submit this shit. We need not take modulo because the numbers are small here, okay? Will I overflow somewhere? I don't think I'll overflow somewhere. 2 power 30 itself is less, so NCR will be less than 2 power n, right? So this got accepted. Is it clear, guys? Is the problem clear? Sure, I'll learn. Oh, I forgot about the duel. Maybe he texted me on Telegram. I missed it. Like the video, guys. You guys got to learn NCR, right? Properly. Saying I gave you D. How are you doing, Vedant Pandey, though? So guys, now let me solve E and F. Like the video. I'll come back to C, but let's see this problem before that. We call an array of n numbers. We call an array of numbers k exquisite. K exquisite. See, you have to realize that there is no knowledge in Codeforces problems at all. Have I used any knowledge here? No knowledge, because I was able to write this down. I was able to. This comes from the problem itself, right? So don't get cheated like by thinking if this is DP, if this is that, if this is that. Don't hear anything negative. Don't hear anything that makes you think you cannot do something, okay? Because it's not knowledge, like it's, you can just, if you try slowly. We call an array of numbers k exquisite if it has at least 2 elements and any adjacent numbers differ by at least k. So it should have at least 2 elements, so the size should be greater than 1, and at any 2 adjacent elements should be differing by at least k. So if any of the adjacent numbers differ by less than or equals to k, less than k, that's a bad array. Otherwise, it is k exquisite. You're given a permutation p of length n. For each k 1 equals to n minus 1, find the number of k exquisite subarrays. So we have to count shit here. N is big. We have to count shit. Maybe we have to simplify it a bit, right? So you have to see very clearly here, because they're asking you, see, CP doesn't have too many ideas, because math may not have too many ideas, right? Because ideas are very unique. Ideas are not like ideas in the sense, I call seeing the complement as an idea. If you have a set S and you have a set K, which is subset of S, if A is complex and S minus A is simple, look at S minus A. This is a great idea, probably called complement or something. Okay, these ideas are not too many things. Like, let's say you have 100 green balls or something, in that 100 total number of balls, and then you have 3 green balls. Would you count the number of red balls as 97 one by one, or will you just see, okay, there are just 3 green balls, so why not do 100 minus 3 and do 97, and find the answer as 97? Because you have to look at what's simpler. So that idea we use a lot. Okay, so now let's look here too, because k equisite means size greater than 1 and all adjacent values greater than k, at least k. Okay, so if you write it for some subarray b, let's try to just define it for some subarray b of length m. Okay, how do you define that? What are the conditions for b? M greater than 1, comma, absolute of bi minus 1 greater than or equals to k for all 2 less than or equals to I less than or equals to m. That's it, right? This should happen for a good subarray. Okay, for all. So it's like and of some many. So this should happen here, this should happen here, this should happen here, this should happen here. So with respect to k, let's look at a. Okay, some indices might fail this in a, right? Some indices might fail. Okay, so all the I from 2 to m must satisfy this, but some might fail here. Okay, let's look at indices for which some might fail. Let's look at indices for which a of I minus 1 is greater than or equals to k. Let's call these indices good. Okay, so now we have some green indices, some red indices. We are seeing it as indices, guys. We are not even seeing subarrays or something. We are just looking at one index, and we are seeing for that index I, we will see the previous element, and if absolute difference of them greater than or equals to k, then that is a good one, else that is a bad one. Okay, now if you have L green indices in a line surrounded by red indices or ends, you have to be careful about the ends. Okay, because if you define these colors, k equisite means I equals to 1 can be anything, and for rest all are green indices. That's it. That's what a k exquisite means. So now we have to see green indices in a line surrounded by red indices or ends. I equals to 1 is an n here. Okay, because for I equals to 1 we don't define. For I equals to 1 we don't define green or red, right? Answer, it's not answer, it seems it's answer. Let me see about that. Answer, answer, but in Indian pronunciation it's answer, I guess. Suck my dick, Pradeep. It's answer in Indian pronunciation and even in British pronunciation. And here it's just answer. Answer or answer, any of them will work. Okay, if we don't define green or red, right? What does that mean? Yeah, for I equals to 1, so we will see number of greens in a line. Okay, so let that be L greens in a line surrounded by reds or that. Okay, because every green will have a previous index. It's just choosing some subarray of these L greens. Okay, what is the number of ways to choose a subarray? You have to choose just some subarray. What would be the number of ways to do that? Choose two indices, okay, and fill them up. So it's about choosing two indices if the size is greater than 1. So it's just LC2 plus L. If size of greens greater than 1. Okay, if size of greens greater than 1, if size of, because size of greens can be only 1 because you're anyway taking the before thing, okay? If size of green is 1, it is L, else it is LC2. So the answer is LC2 plus L, okay? If you have a size L. I'm not sure if my answer is right or not, but my answer pronunciation is right or not. Okay, but now how do we solve it for all the numbers? As you increase k, number of good things will become less. Okay, as you increase k, number of good things will become, some greens will become red. If some green is becoming red, what is happening? If the green segment is this, that green will become red and the green segment will become into two things. Okay, so if we can have all green things, green segments, lens at each step, we'll try to increase k. Okay, by increasing k, some greens will become red, because if you increase k, some greens will become red. If k equals to 0, initially everything is green. At each step, if you can maintain this summation for all the segments that are there, then you can likely solve the problem. Okay, because if you know what is the segment on this thing, you can make that green as red, and then the segment will split into two things of size this and size this, right? Is there a simpler implementation though? Is there a simpler implementation? We need likes, guys. We need viewers. How to solve this one? How to solve quick? I guess I cannot waste time. I will end the stream by 12:30 at max. I cannot do this more. I have important things to do. Is there any other way to do it? Likely not, right? Pam, 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 para, para. Or if you have reds in a set, greens are nothing but adjacent red difference. So I think I have done something like adding some things to a set, and then you will try to see what happens to the adjacent differences. This difference will be removed and this difference plus this difference will be added, right? So you can do in that way. Let's say you have some reds, you're adding a new red, you will remove this difference and then you will add this difference plus this difference. If L equals to 0 or 1, if L equals to 0, the value is 0. So you can have reds and you can have another set that has red differences, and you can not even another set, another you can have another thing that has answer, because when two red things has been removed, you know what has been removed, so you will subtract that and then you will add two smaller red things. Okay, so let's maintain reds in a set. Okay, let's try to do this. We can do this. But how big is k? Is k fixed? No, k is not fixed. It's a permutation. We have to find this for all k, right? Yeah. I'm hungry. Guys, I work at One Mind. One Mind is a very good company. You guys should try to apply if you think you have some good skills, okay? Even if you don't have good skills, maybe in future you guys can try to apply to One Mind, okay? Uh, they're letting me, not letting me have to do work too, but yeah, I should not be doing this shit. So let's try to add when something should get activated. When index I should get green. Okay, when should index I should get green? Vector int idx activate, let's say. I less than n I plus plus. Okay, for this the k is absolute of a of I minus a of I minus 1, right? See how I have colored indices. Now I'm only looking at one indices. So that's the beauty in writing things mathematically. Okay, you can only care about I and I minus. You can only care about I and I minus 1 in I. You will represent that with index I. Okay, and activate of k dot pushback of I, because when k is greater than or equals to this value, this index will get activated. Okay, so let me try to write when it will become. After this it will become red. Okay, before this it is green. After this it will become, wait a minute, yeah, till here it is gray, it is green. After this it will become red because greater than or equals to k is green, right? After this it will become red. Okay, so what we have to do, let's say red indices become start from 0. We can make 0 red because 0 is not taken anywhere. We can make n plus 1 red. 0 red dot insert of n, let's say. Okay, and initial answer is L plus LC2, right? Initial answer is n minus. I mean, if the differences between that is that if L equals to 0, return 0, let's say, else L minus minus, and then let's do this. Because what I mean is, what do I mean? What do I mean? So if L equals to n, it will become n minus 1 plus n into n minus 1 times n by 2, which is right. Wait, we have to do n minus 1. I'm not getting it. 1 minute. And in between we have n minus 1 greens, right? That's why I'm doing that. If there are n minus 1 greens, what is the answer? If there are n minus 1 greens, what is the answer? Yeah, the formula is nc2 plus l, right? Yeah. That's why it was not adding up. Now if I see it, it might add up. And now it is adding up. Sorry. So initially we have answer to have, we have one red at 0, we have one red at n. We will keep adding reds in between. And once you add a red in between, we'll try to see what the previous difference was, and then we will subtract that, and then you will add the new difference. You will add a new thing, okay? K equals to 0, k less than or equals to n, k plus plus, okay? So you have answer, initial answer. And then what you should do, you have to subtract for all these indices. So they will become inactive now. So what you have to do, you have to make them red, because for the next k they are red, right? For the next k they are red, right? K won't be 0 because adjacent differences of a permutation are not 0, right? So now we have to just remove them. Okay, you have this set red, you have to add this into red. Okay, auto f equals to lower bound s dot lower bound idx, let's say. Okay, this will exist, something greater than that will exist, so let that be, that will surely exist, let that be r. Now do f minus minus f, because we have 0 and n, they will definitely exist because these are in between things, right? And now let it be l. Okay, this two will definitely exist. Okay, so you have to do r answer minus equals to fun of r minus l, and then you have to add idx into that, and then you have to do answer plus equals to fun of idx minus l, answer plus equals to fun of r minus idx, and you're good. We are doing it sequentially, right? See, we are being good. And again, is this problem having too complex of a code? No, right? It's having some steps. You guys might learn so many amazing techniques of me, like see the programming, like see the niceness. I think I have to do it like this so it looks more nice. R minus L, R minus IDX, IDX minus L. R dot insert. So now where are we? How much time has passed? I'm not sure will you get expert or not. Do good in the next contest, you will get expert. Okay, do good in the next contest. It's not that difficult. Pronunciation. Okay, I learned that. He sees my streams, Shubham Tanwar. Isn't that obvious? That should be obvious. And this should be accepted. Maybe we can use DSU to connect things. Maybe we can use DSU to connect green things. Should I do that implementation? Should I do that implementation like whenever this becomes green, it will try to connect the previous thing if that was also green, and if you try to connect this if that was also green. So now we will have these green components, and whenever we have a green component, we will find this fun again for that green component, but this time there won't be L minus minus. So I'll try to do that. See, vector int comp define n. We don't even need comp, right? We need parent, and we need find parent. Return. Now what is the what is this shit? We have answer equals to 0, let's say. In x and y, you're trying to combine these two things into one set. Parent of I equals to I, size of I equals to I. Let's say initially everything is red. Let's say initially everything is uh, red, and then you will make one thing active. Okay. You have greens, you have green component. But if a green component is initially not present and initially active, based on that we have to update it. We'll make something active and then we'll try to connect it. Okay. We are trying to make something, some red as green, and then we'll try to connect it with the beside thing and this side thing. Okay. We have to connect them and count the value. Okay. Else so initially sizes for sx and sy, right? So we are removing them. We will add fun of sx plus sy, which is nothing, sx plus sy. We'll update size of py2 plus equals to sx, and then we are done. We should also do this. So now we were able to connect two things. Okay, but remember initially all the red, everything is red. We are coming from behind now. Okay, we are coming from behind. So at k equals to n minus 1, some things might become green. Okay, some things might become green. All of these things will become green at the beginning of that. Okay, if it is becoming green, first time it's becoming green, what you have to do, answer plus equals to, if it becomes green, fun of 1, because it just became green, it's not yet connected yet. Okay, now what you have to do, for all these indices, let's also make it like, let's also maintain an array called green. Okay, for all these indices, let's try to connect them to their, because these are the new greens, let's try to connect them with the previous things and the other things. Okay, if green of idx and green of idx minus 1 union sets of idx comma idx minus 1, if idx less than n, okay, if green of idx and green of idx plus 1, because only it can get connected with adjacent things, right? So if you guys see how I am coding, I will make sure that some things will work, and then I don't overthink about things. Like what do I mean by that? I'm making sure the format for answer is, whenever a new thing gets added, I'm updating answer, and whenever things get connected, I'm updating answer. Whenever things get connected, and now I'm trying to force connections. No, we're trying to force all the connections. So we made some things active, some things became from green to red. We don't think everything at a time. We don't think everything, okay, something is becoming active and then it is getting connected. It's too complex. How they will connect? We don't see all of them. First, we are making things active. Now we are trying to connect them to their adjacent things. And then if they are already connected, we will just return. Else, we'll connect them and update the answer accordingly, right? So after connecting, after making things green and updating, you will have, let this be vector int f answer of n comma 0 or something like that. We'll have f answer of I equals to k greater than 0, right? F answer of k equals to answer. So also this would work, right? But it's telling it has some error. We have to initialize something. Thought you were too good for me, my dear. Never gave me time. I thought this will work because IDX is never 0. IDX is from starting from 1. I thought this would work because IDX is at max n minus 1, right? And n minus 1 and n are active. So that worked. Except it's giving wrong answer for something. It worked. Oh, L minus minus no longer exists because we are having correct sizes, right? So we could have done that with DSU too. How long did it take for us to change the implementation? 10 minutes. And this is a bit faster and less memory too. But it's about solving the problem, I guess. After solving the problem, you can use similar formats. The one was having red, slowly things become everything green and things becoming red. So you disconnect things. So we have that set and then we are disconnecting things. The other one was everything was red and then you're adding, making them green and then you're just connecting things with DSU. So do I. Maybe you're not applying, maybe you're not trying more on your own, maybe you're not doing something that he's doing. Try a bit more. Be more optimistic. Even I have to be optimistic when trying problems. You're given a rooted tree with n vertices. The vertices of the tree are numbered from integers 1 and n, 1 to n. The root of the vertex is number 1. In each leaf of the tree there grows one cherry. You want to collect all the cherries, and to do so you perform the following action several times. The root of the tree is vertex number 1, and in each leaf of the tree there grows one cherry. You want to collect all the cherries, and to do so you perform following to do this you perform the following action several times. You choose any vertex of the tree V and shake it. After this, cherries fall from all the leaves of that descendants that are descendants of vertex V. If the vertex V itself is a leaf, then a cherry falls from it. If a cherry has already fallen from any leaf before, the tree will break. If cherries have already fallen from any leaf before, the tree will break, so such a situation must be avoided. So we'll only shake few times. Is it possible to collect all cherries in this? We choose any vertex of the tree V and shake it. After this, cherries fall from all the leaves that are descendants of vertex V. If vertex V is a leaf itself, the cherry falls from it. If cherries have already fallen from any leaf before, the tree will break. So what does that mean? If you do one thing, you cannot choose anything again in the same subtree, or you cannot choose anything in the same subtree, or you cannot choose in the above, because then you will again use the same thing, right? Is it possible to collect all the cherries in this way? By selecting a multiple of three things, can you split the leaves into a multiple of three things is what it means. Okay, is it possible to do that? So what it is, 1 2 1 3 1 4, right? You have three things, you can choose 1 2 3 cherries, so it is possible. You have 1 2 2 3, you have only one leaf, it's impossible, right? So when it's a nice problem, this is an, I mean, nice in the sense it may not be too difficult, it may not be too nice, but it's something simple. I mean, it's not simple, I mean, it might not be too difficult for me, or I cannot enjoy it because it is not difficult, I cannot enjoy it. But it's a nice problem for you people to try, right? You have to think about a way. Okay, is there a way to choose some multiple of three things such that you can remove those, you can remove that shit? Pum, pum, pum. So if number of leaves itself is multiple of 3, then it's done, right? If number of leaves itself is multiple of 3, that's a small observation you can write immediately. If you even try a problem, it might not be too difficult problem though. Then done. Okay. Now, if total leaves equals to 1 or 2, means if the remainder is 1 or 2, okay. If you have a leaf, if you have a subtree whose remainder is, whose reminder, when I say subtree's reminder, I mean reminder of its leaves, okay? Because we have to collect some vertices which are 3 multiple, okay? And with respect to total leaves, this subtree corresponds to its leaf size, right? If its leaf size is 0, that subtree 1, you're subtracting 0 and then you're adding 1. Okay. So if you see here, what I'm trying to do here is, you have this number of leaves, you will group something into 1. So you're subtracting this size and then you're adding 1. You're doing it several times so that the remainder becomes 0. Okay. So if the remainder is 1 and if you can group 4 things, you're done. Right? if the remainder is 1, okay, if the total, if the remainder of its leaves is 1, let's look at 1. Total leaves equals to 1. Okay. If you find two leaves together, it's done again. Because you'll just group those two things into the above thing and then it's done. So means if you find some vertex whose size is 2, you're done. Because if its size is 2, you can do size minus 1, right? Size minus 1 is 1. Let's call size, or let's call value. Value is 1, you're done. You will remove that one thing. What do I mean by value of a subtree? Number of leaves minus 1. Because that's the thing happens when you try to take that. You will remove all this and then you will add that, right? So number of leaves minus 1 is the value of the subtree. So now my question is, you have these value things. If total leaves remainder is 1, will there exist a way in which you can find something of value 1? If you don't find value 1, because now you have three n things, right? Three multiple things. If there doesn't exist, we're looking at optimal. Some vertices, okay, some 3z vertices whose value adds up to total leaves. Total leaves remainder 2. I mean, their value should add up to total leaves inverse, right? Adds up to 3 minus total leaves. Okay, because when you add value and total leaves, it becomes 3 multiple. I'm complicating things because I can complicate, but it's not like difficult. What I mean is, okay, I'm trying to see it like that. We have leaves, initial leaves, which are adding up to something. And then when you try to take one, that's the value of that. That will get merged with this, which is nothing but removing leaves and adding that. Okay. So value adds up to minus total leaves is what I can write. Or so if there does not exist a node with value 1, okay, among these three jet things, if there is no value 1, means all of them are value 2 or value 0. But with value 2 and value 0, if you're having, okay, I see, if you're having three jet things, you can do that. I was trying to say something, but it doesn't work. If total leaves is 1, you can do this. Wait, what am I doing? No, value of node is not minus 1. Value of node is total minus total plus 1 is value of node. Plus total will only give you 1 and not 0. I was trying to see if there must exist a value of node 1, so that we try to remove that, and then it becomes multiples of 3. I thought like only one will be a group, but maybe you can have many groups. Maybe you will have if there does not, maybe okay, if there exists a node with one, I think 1 and 2 are equivalent here, then you are done, right? Because you will just take that, you will just add that value with value 2, you're done, let's say, because you'll just add that value 2 to 1. Okay, you have 1 here, you will add that value 2 to 1, and then you're done, you got 0. We are considering total value is 1, so if there exists a node with value 2, we are done. Else all nodes have values either 1 or 0, right? Now if you can find two nodes whose values are 1 and they are in different subtrees, because if you are able to attain value of 2 again, but you're using different things, even now you are done. Yeah, now it's all about seeing if there are two nodes whose values are 1 and 1, but they are in different subtrees. Even then the answer is yes, and the problem is done, because if this doesn't happen and the remainder is becoming 0, means the value you are able to add 2, the values you are able to add is 2. If the value you're able to add is 2, there exists a subtree with node value 2, or there are at least two ones, because if there are no two ones, you cannot get value 2, right? I think the same goes for the other thing. So it's all about, I have seen this long ago, I think I have to use my intuition more, because many times I can feel the solution intuitively, but then I never use it. I just wait till I try to get through it logically, not even logically, through writing things down. I have to learn to use my intuition, because even in C last time, easily I got the solution. Okay, leave that. I'm tired. I'm very tired. So, guys, this is the problem. If the total adds up to 2, you have to find values of if some node is 2, or if there are two nodes in different subtrees that are having value 2. How do you find if two nodes are having value 1 and are in different subtrees? You can just see for node V, you can see all its children. Okay, if two of them have node with value 1, you're done, right? So let's say I will just maintain This problem is not that difficult though. I can code it quick. Did you guys understand the problem? I introduced something called value unnecessarily. Say guys, I'll show you people anime girls if you are bored. See, we have some anime girls over here. See them boobies. So you guys stay in the stream. We have many one. We have Makima, we have Bunny Girl Senpai, we have Komi Can't Communicate, we have Yuri, we have My Dress Up Darling Girl. And we have High School DxD2. We have Ace. I'm Ace. I forgot the main character of High School DxD, but I watched it long back. We have Ace. I cosplayed as Ace 2 days ago. I have cosplayed as Ace 2 days ago. And my brother does lots of cosplay. It's all messed up over here. Yeah. No, I don't have a hickey. I have recently done a cosplay. I have recently done this cosplay. Uh Wait a minute. I have done this cosplay recently. So I was trying to not have any hickeys on me because I have to go shirtless, right? If I have hickeys, it looks vulgar. So I tried for that. This was 1 year back, but recently again I have done the same thing. You can see the hat is differing, right? I'm not an experienced guy. I'm a good guy. I'm innocent. I have to work. I'm working remotely. I have to work. Currently, I'm in Hyderabad. So if you guys want to do Hyderabad meetup, I don't have enough fans. If I have enough fans like some other competitive programmers, I'm just an expert. Maybe if I reach my goal is IGM. I'm not compromising on GM because everyone is a GM these days, right? GM is too bad. I won't even celebrate, I guess, when I become GM. I'm staying in Bangalore because it's more lively, I guess, right? That's why I'm staying in Bangalore. Also, my most of my work people are in Bangalore. I think they will keep an office eventually in Bangalore. Okay. So, guys, how is my value thing? I'll implement it very quick. Okay. So we have a total value. So how do I know if there exists a node with value 1? So let's say uh, I'll just do it brute force. Okay. Define n. I just do it brute force because it's simple. Int. I will keep if v1 exists or not, value 1 exists or not, value 2 exists or not. These are two arrays. Okay. I will find values of all nodes, which is just sum of leaves minus that. Okay. Value of e equals to 1, let's say, and then what do we do? Value is leaves minus 1. Okay. Let's keep it minus 1 and let's add leaves. Because value is leaves minus 1. If you do DFS value, you'll have value of u. Okay. Now what you should add is leaves. You have to add leaves in this. Okay. So what do we have to add? What we have to add is value of v plus equals to value of u plus 1. Okay. Because leaves, number of leaves in this is what we have to add. Now we have all the values. Okay. Let's just find count of v1s. Okay, let's find count of v1s because no, count of v1s is bad. We want v1s to be in different subtrees, right? So count of v1s is bad. We want to know if v1 existed or not, because we want one to be here and some one to be in some other subtree so that we can choose those two ones. You guys get that? So this value 1 will become 2, and once we group those two things and leave remaining things as leaves, we are good, because these values will get added. 1 plus 1 will get added to 1, the total value, and then you are done. So what do I do? If value of v equals to 1, v1 equals to 1. If value of v equals to 2, v2 equals to 1. Okay, or if some of the subtree is having, after you leave, you have to be careful. If you should not do before entering the subtree, because now you're leaving the subtree. So after leaving the subtree, you will have v2 also recursively, let's say, and by leaving the subtree of, you're having v1 v2. If v1 of u, because if it is having 1, then v1 of v equals to 1. If v2 of u, v2 of v equals to 1, which is nothing but if there is some value to, I'm complicating things because that's simple to me, because if I make things clear and then do complex things, that's simple to me. That's why I'm just complicating. Now what I will do is now I'll try to see for something among its children if there is, let's keep parent 2, okay. Rooted at node 1, right? I need more haters, guys. If I get more haters, then I will grow, I guess, because I'm not having too many haters. I'm having little bit of haters, but not too many. So we have some guy hating grapes. We have this guy who is real deal. Stop using that shit word while solving. Shit. Such a shitty comment. Stop overreacting while with your fake accent. I hope I have an accent though. And seriously, get a life, bro. Go talk to people, make friends. Chill, chill. Maybe I have to take some advice from that. Maybe. So what is v1? Is there a 1 in the subtree? Is v1, okay. Now what we do is, in total equals to, what is total value? Total number of leaves. It is 1 plus value of 1, okay. This is total value, okay. Because total value is total leaves minus 1, right? Okay, we have to do reminder 3 everywhere. When you leave, it will have perfect reminder 3, okay. Else, if, I'll split things now, okay. If total value is equals to 1, if v1 of 1 S. Else you have to check. Else you have to check if there are two ones, if there are two twos. So for that, what do we do? In different subtrays, so we brute force V. We go over its children. We try to see number of twos in different subtrees. Okay. In count of twos equals to. Now we are ignoring parent. Now if V2 of U, C2 plus plus. So let's just, if C2 is greater than or equals to 2, let's just return, because some children is having 2, some other children is having 2, means you have 2's in 2 different subtrays. We'll return. See, these are all if else's. So we come here I'm deciding finally. If sometimes it comes yes, else it's no. So it's all done, very clearly done. So we'll do this again. We'll try to find ones now. It's either there is a 2 or, so the total value is 1. So the value we add to that should be
Connected.
the fuck.
Disconnected.
Shut the fuck up, you're scaring me. I mean, value is being initialized, but the other things are not being initialized. Or maybe I'll initialize them here. Damn, it's being scary now. Total value is 1 here, right? I'll just output values on C. So for 1 it says 2. Is that correct? Because you have one thing, 1 minus 1. For 1 it should be 0. For the last thing it should be 1. Okay, I have to make it, if it is if it is a leaf, I have to make the value as 1. How do I do that? If it is a leaf, leaf's value is 0. Leaf's value is not minus 1. It's becoming complex. I have to write it here itself. Were you guys able to see the previous problem getting accepted? This one. The error was the I was pushing x to x. That was the error. Other than that, leaf value we are fixing. We're finding values of others. And then we are just doing the problem. So we have proved the problem well. We proved the problem very well. Okay. What is value? You have total. Value is what happens when you choose this subtree. Leaves minus 1 will get added to the total value, right? Sorry, 1 minus leaves will get added to the total value, right? Wait a minute. Did I do something reverse? But still it worked out. You guys understood the logic, right? You have some values contribution of every node. Okay, leaves value is 0 to the total summation. What about other things value? It's 1 minus that, let's say. Now, if there is something that if total itself is 0, you're done. If total itself is 1, if you have it 2, maybe you can add 1 and 2 and then it becomes 0. If you don't have 2 at all, means if there is an answer there were two ones, you will add those two ones to the total one and then it's done. It's like either you take everything or either you take everything individually or you connect one subtree or you connect two subtrees. That's the answer. You need not connect more than two subtrees is the answer, is what it says. Okay, you can always just connect at max two subtrees, and we are brute forcing two subtrees. If you are connecting two subtrees, they should have same reminders, right? So in some way people can guess this easily because they will guess, okay, at max we need two subtrees to connect. I complicated it by saying reminder and then coming back and then saying that if the reminder is non-zero we will have two things for sure, but people will try easy solutions, right? If there is a one subtree that gives the answer, done. Or else can we find two subtrees that gives the answer? I'll end by 12:30, I guess. I'll try to one more thing and I'll end. Andre remembered that he has n blocks numbered from 1 to n. On the block number I, there is an initially. He arranged them in a row in increasing order of the numbers. First block with number 1, then the number, and so on with the block with number I n and then. For a certain segment of consecutive blocks, we call integer the nasty if minimum of all of them equals to d. So for L, you call D nasty. So for a segment, you call D nasty for a segment if all of them has a minimum equals to D. So first D thinks there should be D as minimum. Change the number AI written in the block ith block to X. Determine the nastiness of the segment L and R. The nastiness of the segment refers to the number of nasty numbers for that segment. So we want number of nasty numbers in a segment. We want, Andrew couldn't figure out how to process this queries quickly. So yeah, we have to first work on how do you find nastiness of some segment? What does it mean to find the nastiness of some segment? Let's see, because let's say you have one segment as nasty, you have one minimum D as nasty. I think it's all either 0 or 1 is the answer, because if you have one thing as nasty that says D is here within this, you cannot have D plus 1 as nasty again because D is anyway present before that. So if you're taking more things, minimum cannot be D. So that's an obvious giveaway. Like you either have no nasty or you have one nasty. Okay. You either have no nasty or you have one nasty. So answer is either 0 or 1. That is an obvious thing you can say if you try to read the problem a bit. So now it's all about determining if there is a nasty D or not. We have to see if there is a nasty D or not in this. How do you determine that if there is a nasty D in that? If AL equals to 1, you have a nasty D. L equals to 1. If AL equals to 2, if something in that is equals to 2, you have a nasty D. If something in this equals to 3, you have a nasty D. You can try to see how. Oh, we are changing numbers too. We're changing numbers too. And then we want very quickly. How to find the nastiness? Okay, if nasty number is due, what are the necessary conditions? I haven't used necessary conditions in the whole stream. Now I'm using it. I might have used necessary conditions, but I haven't used the term. Uh, if D is nasty, like mine, uh, we have greater than or equals to D values for greater than or equals to D prefix elements. So that means we have greater than or equals to D values for greater than or equals to D prefix elements, right? I'm not able to do this. Let's say I have to go by that. I'll try to do easy problem C, B, A, and then I'll stop the stream. Okay. I can do this, but I cannot. I have some things to do tomorrow, so I'll just try to quickly do C, B, A to complete my stream for newbie viewers or new viewers. Andre has a huge pile of n apples. He can divide the pile into two smaller piles of x. If there are x apples in the pile, he will get piles x by 2 and x. This division takes 1 minute. Andre wants to eat k apples, but he doesn't want to count them at all. That is why he wants to obtain a pile that contains exactly k apples. Determine whether it is possible to achieve this by performing pile divisions. So, what does that mean if it was possible? What all you can get by doing these things, by doing these divisions? You have x and x seal. If you try to do divide them again, these two might be same. But can these two be different? It seems difficult to me. Because I try to come from optimal, right? Or like not, I try to solve the problem, right? Rather than trying to find a procedure. Okay, if he has 8 apples, what does that mean? I can think of something like some ranges are possible. And if you know these ranges that are possible and these ranges that are possible, maybe we can add these ranges that are possible. But okay, let's say you start from k. Can you go back? Can you always find how to reach from k to x? Let me try b and a. Vadim's hourglass measures as minutes. He flipped it over and the time started. Every k minutes, Vadim will flip his hourglass again. He will do this even if the sand is still falling. Also, if the sand has already finished falling, but there are still some minutes left. Why are all problems difficult? Why are problems getting difficult here? It has so many things because if it has come down, it will be empty and then you will flip. So we have two sides, right? We have two sides. For a hourglass, we have 0. We have the other side is s. So what happens when you flip? It becomes s comma 0. If it was x comma y, when you flip, it will become y comma x. And then this keeps reducing, this keeps increasing. Okay. So it was going from here to here, and then it comes from here to here, and then it is going from here to here, and then it comes from here to here. Wait, why are these difficult? All are big values. And it can be 0 s for long. This is not easy, right? Let me try a. I mean, if you see the structure, it's not that easy. You have these things. If you have s coming slowly to 0, and then you have this going above. In between k comes, and then it reverses above, and it might reverse again back if k is like small. Okay, maybe in cases I'll see. If k is less than s, then you will flip. Less than or equals, this will fall. And then you're flipping back. And then that will fall. And then you will flip back. Then it is simple. You have remaining plus k 0. After k minutes you will have rim comma k, and then again after k minutes you will have rim plus k comma 0. So remaining will just stay in this thing that keeps coming, keeps coming, keeps coming, keeps coming. So each time only k thing will fall, and then again k thing will fall. because we are flipping. But this is not easy. Even after this, okay, if k greater than s, all false, and then all false, and then all false. K is greater than s, everything fallen, and then you flip, and then everything. I thought k will come in between somehow, but it's never coming. Yeah, so it's not too complex. K greater than x, all false, all false, all false. So if k greater than x, we have to see when was the last flip have happened. And from there onwards, how much has fallen here, and then how much more will fall here from here. But it's not an easy problem compared to other problems, compared to E and F, compared to E was more direct to me. Even I'm not liking to solve this problem. I don't know if it is an easy problem or not, but I'm not liking to solve this problem because it falls. If m was in between, last fall is this, right? If m was in between, we have to calculate this. If m was here, we have to, it is 0. If m was, it's not easy. I mean, I can write the formula. I can understand. Okay, if this is the difference, if that difference is less than or equals to s, the answer is s minus that. If else the answer is 0, I can see that easily if I try to, but I was not somehow liking to do that. What about here though? For the before k, based on even or odd, you know if remaining is in the top or not, right? So you will start from there. From there, everything falls, and from there, either this much is falling or this much is falling. If this much is falling, it's this graph. If only remaining is if only k is falling, it is k graph. Else it is s graph. So for k graph or s graph, you have that. If it is within s, it is like s minus x. Else it is that. So you have to find the last kth value. So I mean, if I try, I can, but it's like. So we have these many flips, right? Okay, if k greater than s, what is it? Here we have flipped. Everything is going to fall now. If everything is going to fall, answer is C out. Wait. Wait, wait. Wait. Okay, this is not that complex. Here the answer will be after he leaves, we want to know the answer. So we have to know the answer when he's leaving. So what I was doing was right. If r less than or equals to if r equals to 0 means he just flipped it. So the answer will be k. Else we have this graph. I think r equals to 0 also works out. So answer is s minus r. R equals to 0 is right. or equals to 1 is also right. That's it. Because he is definitely flipping before. The length cannot be more than r because he's flipping before that, right? The last flip. In this case, based on the q's, if q is 0 and then q is 1 here, right? So if q is 0, all of them has fallen. Like you have rem in the above and k has fallen down. Then you will have k as above, so rem will be 0. Initially you have k as above. If it is even, you will have rem in the above. If it is even, so here it is k minus r. Because from here k thinks is about to fall, right? But if q reminder 2 also equals to 0, also rim will get added because it's an even thing. This is still complex. I don't know how people are solving it. I can do this. Wait, when did div 3b become difficult like this? There's so much logic in here, right? When did they become difficult like this? So we are having groups first and then we are dividing them into two parts. When is 0 possible? Even this is not easy. If n is even and big, you can get 0. Why? You split that into n by 2 comma n by 2, and for this n by 2 you will split, take them 2 2 2 2. If it becomes 1, we'll try to take these 2. That would be 3. So when is this possible? If n equals to 4, so n is even and n by 2 is also large. How large should n by 2 be? If it was 1, it's impossible. If n by 2 is 1, means if n equals to 2, its answer is 2. N equals to 4, you can have 2. If n equals to 6 also it works. 3 also you can just keep it 3. Answer is 0 here for all. Okay. So now let's see about odd. If n is odd, can you make it 1? I think using the same above example, if n equals to 3, you cannot help, but the answer is 3. If n equals to 3, you cannot split, the answer is 3. 3. But if n equals to 1, what's the answer? It's impossible to do if n equals to 1, n greater than or equals to 2. N equals to 5. Can you always make into two groups of size n by 2 comma n by 2 plus 1, which would be 2 comma 2 plus 1, or 3 comma 3 plus 1. 2 comma 2 plus 1, you can group them. 3 comma 3 plus 1, all the big numbers you can group them, I think. So it should be fine. Answer is 1. We'll submit this. I'm ending the stream, guys. It's too much.